Hi, my name is Dr. Jordan, and I'm here today to tell you about the contents of the supply kits that we've given you for the Fall 2020 EGR 304 course. Now, these supply kits are available in Peralta 109 from Sheldon, and if you haven't picked yours up already, please do. And they have basically everything you need to be able to complete the course this semester. One of the first things that you'll see is a separate soldering iron kit that has within it a number of really useful parts. So there is a pencil soldering iron in this kit, as well as a soldering sponge. And the way the sponge is used is when you're soldering, very often you need to wipe the tip off while it's hot. So if you wet the sponge and then put it next to the soldering iron, you can wipe the tip off and clean it. Also in this kit is a soldering stand. So this stand, if you fold up the little yoke, then it gives you some place to rest the soldering iron while it's on the table, so that's really useful. And then beyond that, there are just a number of different useful parts. So there's a desoldering pump. There are some very fine tweezers, which are great for particularly smaller parts. There is some wire that can be used. There is a wire stripper, and there is a small screwdriver and some extra tips for the soldering iron, some electrical tape, and last but not least, some solder. Now, the solder that's in these kits, as well, both this as well as the other solder that we included with the kits, which is some Kester solder, both of these solders are lead-free, which means that they are safer for your health, but harder to solder components with. But the good news is, again, is that it's better for your health. So we included this second tube of Kester solder. Kester is one of the top brands in solder in the world, and so we wanted to include another option in case the solder in the kit is not working well for you. There are a bunch of soldering videos on the blog. If you go to the last menu, then you can find those as well, and those will give you some tips on how to solder. So that's part of the soldering. Outside of that kit, but also in the bag, we've got a few different things. We've got some desoldering wick, and there are videos on YouTube on how to use this, but basically think of it as like solder vacuum. And so you put this wick down on top of a ball of solder, and then put a soldering iron on the edge of it, and then it'll suck up the solder through that wick. So it's a very useful tool. It's an alternative to the desoldering pump. Other pieces that we included related to soldering are, this is a liquid flux pin. And the way to use this, so flux lets solder flow. And so let's say that you've got some solder that is shorting out several pins on a chip, and you have tried to reheat the solder, but it continues to bridge the pins. Then what you would do is take the flux and shake the pin up first, open the pin, and basically paint over the area of the solder where it is bridged, and then go back in with your soldering iron and reheat. And what flux will do, because it allows solder to flow, the solder will move away from the non-metal parts, meaning the gap between the pins, and toward the metal parts, the pins themselves. And that's a great way to help solve a number of problems. Other things that are in the kit that are useful, this is the main microcontroller that we'll be using this semester. It's a Cypress PSOC 5LP. And when you pull it out of the container, you'll notice a couple different things. So one is there's a USB port on the back of it, but it doesn't have the metal shroud. So you can plug this directly into your computer USB port, but be forewarned that because it doesn't have the usual metal shroud around it that you'll see on other USB cables, that sometimes you have to wiggle it a little bit in order to get it to make contact. The other key thing to note is that as it stands, it is literally just a circuit board, and it does not have any headers on it. You'll find in your Ziploc bag here that there are a number of different things, and I'll talk through these momentarily, but one of the most important ones are, these are called snap headers. They're male to male, meaning that it's a male on both sides of the header. And what you do is you basically put these into the bottom of the PSOC and then just break off the part that you don't need and then solder one pin at a time across this entire row. And you'll do that on both sides, and on both, you'll see there are two sides of the circuit board. So this side of the circuit board has the actual PSOC that you're using, and then this little break off side, this side is actually a programmer for the other PSOC. You'll need to put headers on at a minimum, you'll need to put them on the main board. But if you're excited, you can go ahead and put them on the other side as well if you're enjoying or just want the solder practice. So that's another key piece. Also, with regard to these, there are some female to male headers that are in this. And so when you get to eventually making your printed circuit board, let me pull this out. When you eventually get to making your printed circuit board, you will need to use female to male headers on your circuit board, so that way you're not soldering your PSOC directly down. And there are some shorter ones and some longer ones. And so what you want to do is make sure that you pair up the shorter ones so that they fill up the entire PSOC. As you can see here. So the female headers, eventually these female headers will be down on your circuit board, and then you'll plug the PSOC down into them. So just make sure you're using the correct ones that match up with the number of pins on the side of the PSOC. So some other things that are in here, we've got a multimeter, and this multimeter is particularly cool. I mean, it's a basic one, but one of the nice things about it is that it has a buzzer in it for continuity checking. And continuity checking is something that you will use quite frequently with it, particularly once you get your printed circuit boards, because the goal there is to confirm that things that are supposed to be connected are, and things that are not supposed to be connected are not. And so that is a key piece. Other things that you will find in here are a couple of USB cables. These are both micro USB, just of different lengths. And these are useful for both connecting the PSOC to your computer as well as connecting the photon to your computer that we'll talk about in a little bit. Other things that you will find in this kit are a breadboard. There are actually two breadboards, so this is one that's separate. And then in this brown box, which is kind of a starter kit of a variety of different things, and you don't need the CD, there is another breadboard in here. So you've got two breadboards to use for the semester. And then also a whole bunch of just really useful components. So this bag that comes in the brown box, it has all kinds of resistors and resistors and buttons and some potentiometers and I believe some LEDs as well, and a couple of headers. So a lot of just useful components. There is also in here, this is an LCD panel that we will use later in the semester to look at some serial messages that are being passed around. Whole bundle of jumper wires. These are great for breadboards and will allow you to construct your circuits. And then finally, a different type of jumper wire that are longer that will allow you to extend things across the entire across your board in different ways. And then finally, there is a nice handy card on how to read resistor color values as well. And so that is also useful. Other things that are in here, this is actually related to soldering too. So there is a knife in the kit as well. This is primarily used for when you get to making your printed circuit boards. Sometimes when you're manufacturing things, you might discover that there's an error in your design or an error in the manufacturing process, that when you've checked something with the continuity checker on the multimeter, it might be connected when it's not supposed to be. And so one of the ways to fix that is to use a knife and basically to scrape the copper off of the place on the circuit board where you do not want it. And so this is really, really useful for rework in particular. Other things that are present in here, so there's a power supply for everyone, and that power supply also includes a special connector. So this is a barrel jack connector that goes to some bare wires. This power supply you will use to power your breadboards, as well as potentially it could be used to power your final circuits. Note that on the end, the wires, you may need to strip them a little bit more to fit them into the breadboard, or depending on which version of the wires, there are a couple of different ones that we got from our supplier. The wires may be too thick to put into a breadboard, and if that's the case, then what you'll want to do is get some of these snap headers and basically solder wires to the snap headers, or take something like these and cut the ends off of one of these and solder the wires to it, wrap it with electrical tape, or there's also heat shrink tubing that comes in the soldering kit, and then you're basically making your own breadboard power supply. So that's really key. You'll need that throughout the semester. Another thing that you'll find, and there are a couple different variations of these, so some alligator clips that have headers on the end. Some, depending on which kit you have, our supplier gave us some that have male ends and some that have female ends. If yours have male ends, then you may need to, I'm sorry, if yours have female ends, then you may need to use one of these male-to-male headers, and you can just adapt it on. Where this is really useful is for your Lab 2, where you're making an oscilloscope and a function generator. This basically gives you your own set of test probes that you can move around to use wherever you need them. Within the Ziploc bag, there are a number, or the anti-static bag, there are a number of different parts, and so I want to talk through these briefly. The first part you'll find in there is a photon. This is a wireless board, wireless development board that you will be using throughout the semester in order to get Wi-Fi in your projects. One key thing to note here, and this will particularly be relevant when you get to designing your printed circuit boards, is you'll note here there's a large rectangular white block on one side. It's the opposite side from the USB port. That is the antenna on the photon. So when you get to designing your printed circuit boards, a great way to keep an antenna from working is to put it in a copper box or to shield it with a copper plate. Your printed circuit boards, before they're manufactured, are bare copper plates. And so you'll want to make sure and use what's known as a keep out area. And we'll talk more about this later in the semester. A keep out area to block off and make sure there's no copper on the printed circuit board underneath where this antenna is. That will greatly improve your chances of being able to connect to Wi-Fi. So that's a key piece. As we mentioned, there are the male-to-male and male-to-female headers. And other than the ones the long header strips, we don't have a particular goal for them. You can use them for whatever you need to throughout the semester. Remember that you don't want to solder your photon, nor do you want to solder your PSOC directly to the board. So in here, we have a set of headers that are the perfect size to fit on the photon. So you'll eventually solder this part onto your circuit board and then plug the photon down onto it. And we also have some that match what you need for your PSOC as well. Other parts that are in here, so there is a power resistor, this big white block. This is basically it's a high power resistor. This particular one will handle 10 watts, and it's a 5 ohm resistor. This is used for testing things like power supplies, and so you'll be using this in a lab later in the semester. Other pieces that you will see in this kit include, there are a couple of MOSFETs, as well as some voltage regulators. So you'll see those in these in this type of package, and those are again used in particular labs. There are also some bipolar junction transistors that come attached to these. There are a number of capacitors of varying values, and so those are difficult to show on this, but we've got a lot of different capacitors. We have 2 different op amps that you'll use in particular labs as well as possibly in your project. And then we also have some things related to light. So there is a photodiode, or I'm sorry, a photoresistor that will change resistance when light goes on it or is taken away from it. And then we also have an infrared transmitter and receiver that you can use for making things like distance sensors. So that is in there as well. Also, and this is at this point, this is only in the kits that got mailed out, but they are also available if your team ends up or if you end up needing them for your project. There is a larger integrated circuit. It may or may not be on a piece of conductive foam that's available that is an H-bridge driver, an L293 H-bridge driver. Those aren't specifically required for one of the labs in the course, but they are required, but you may need to use them for various parts of your project. The last thing that you will run into, so there are two components that you might look at them and think, oh, that's a resistor. And they won't be in blue bags. They're just loose in your bags. But those are actually inductors. And so one of them is a 100 millihenry inductor, and the other one is a 330 microhenry inductor. And those are used in the filtering labs. So we'll get to those. And then finally, last but not least, we have safety glasses. And this is intended particularly for when you're doing soldering. And you might think, oh, I can solder, I don't need safety glasses. But I will say probably the most common injury with soldering is burning yourself through accidentally touching the barrel of the soldering iron or the tip of the soldering iron with a finger or your arm or something. I would say the next most common way to injure yourself with a soldering iron is through balls of solder that are attached to a component lead, and you accidentally flick that component lead with the soldering iron, and then a ball of solder flies off in some random direction. I myself have had the issue where I wear contact lenses, and when I was back in college, I was doing exactly what I just described, of having a soldering iron having a soldering iron, and I was trying to solder or tin a wire and put some additional solder onto the end of a wire. That wire got flicked, and a ball of solder went up, bounced off the center of my contact lens, and landed on the table. And I'm very glad that I was wearing contact lenses, but I really should have been wearing safety glasses instead. So anyway, that is all of the stuff that is in the kit. And if you need additional supplies, then definitely reach out to us. And we also have a number of things available in Peralta 103. So please let us know if you have any questions and post on Slack. Thank you.